Hello and welcome to the Hertford Astronomy Group July 2020 meeting. My name is Alan Willison and I am the chairman. Today's meeting has two parts to it. The first part is a talk about forthcoming events in the night sky and will be given by Martin. The second part of our meeting is a talk about remote imaging given by Nik Szymanek. So without further ado, I'll pass you over to Martin.
Thank you, Alan. Hello, everybody. Great to see you all again. Special evening this evening. Very pleased to be here and to give you a very brief talk about what's coming up in the night sky, and then I'm going to hand over to Nick. I'll start by going straight into my presentation. So I'm just going to take a bit of control of the screen if I can. No, I need to shrink it down a bit before I can do that. Let's try again. Share screen. Right, there we go. So, I hope everybody can see that. I'll go to presentation mode. Right. So I'm going to start off this evening by talking about a new comet that we've got in the sky at the moment. And although I did talk about a comet last time I gave you a talk, it was a bit of a disappointment. The whole thing broke up long before anybody could see anything, and there was very little that anybody saw really. But this one promises to be a bit more interesting. It was only discovered in March, and it's comet C2020. F3 NEO-WISE, and it is meant to be a visible to the eye comet. Now, I did go out the other day. It's only visible early in the morning, about 3-ish, 4-ish in the morning. I did go up in the morning and had a look, and unfortunately it clouded over, so I couldn't see it. But this is a picture that someone's taken of it, and you can see it's quite. You can see the sun rising there, you can still see it, so it's quite a bright comet. I'll go in a little bit more detail, so pardon all the text here, but just to give you as much information about the comet as I possibly can. So, I mean, we haven't had a visible to the eye comet since 1997 when we had Hale-Bopp. So this is quite exciting, really. It is meant to be visible to the naked eye in the northern skies. It should be visible in the UK. I say it is visible at the moment. It's still quite low on the horizon, but as the month goes on, about the 16th, I think it actually is as close to the Earth as it possibly will get. And it's already reached perihelion, so it's gone round the sun and it's going back out into the outer solar system again. So it's going to get as close as 103 million kilometers, which is just in our back garden, really. It's about 400 times further than the moon is away from us. And so the best day for viewing this at the moment is about the 16th of July. So it doesn't mean having to get up early in the morning or go to bed late at night to come and see it, but it would definitely be worth a look. So if I just go to the next one. This is a picture that was taken on the 6th of July in Norfolk. As you can see, it's quite visible, and it's twilighty there. So I think as it gets further and further away from the sun and darker, it will be more visible. So I'm quite hopeful that it'll be a good sight. So just give everybody a bit of an idea of where we're actually looking in the sky at the moment for this comet. So we're roughly about the 8th, 9th here. So this is where it is at the moment. You've got Capella there. You've got the plough there. So as you can see, it's slowly climbing up. So this is the point, the 15th, when it's closest to us. So this, if we get some clear sky, hopefully we'll go out and have a look at it. So I think it'll be quite spectacular. So this is an interesting picture. This was taken in Italy, And this is the International Space Station going across. And there's the comet there. A wonderful picture. So definitely something to be looking at this month. I think it's probably going to be the prize thing to be looking at. So just going back to the last visible comet to the naked eye, that was Hale-Bopp. I don't know if anybody remembers looking at that. I remember looking at it. It was quite spectacular. So this is what Hale-Bopp looked like in 1997. So that was, I don't believe the new comet's going to get anywhere as bright as Hale-Bopp, but if we can see it, I think we'll all be quite nice to see something with the naked eye and not have to rely on a telescope for that. So let's go to the night sky. So quite interestingly, in the southeast at the moment, we've got quite a cluster of planets. We've got Jupiter here, Saturn, and there's the moon all in the south. But interestingly, this month, we have Jupiter opposition. So that, for those who don't understand what that means, just I'll put this diagram up here, shows the sun and the Earth, and there's Jupiter, and all in a line. So this is the closest we actually get to Jupiter in its orbit. So it's a good time if you've got a small telescope. You can see it with naked eye, it just appears as a bright star. But with a pair of binoculars or a small telescope, you can see quite a bit of detail. Jupiter's quite a very bright planet, and you can see an awful lot of detail, even just with a pair of binoculars. You can certainly see at least 4 of the moons most of the time, depending where they are. So it's going to reach opposition on the 15th. So if we got another clear night, that would certainly be worth a look. Interestingly, Pluto's in opposition, but unless you've got a very powerful telescope, I don't think you're going to be able to see that. But there we go. So interestingly, apart from Jupiter being in opposition, there's a nice picture of Jupiter there and 4 of the moons. You've got Europa, Callisto, and Io there. And these are the shadows that are being cast onto the planet's surface. So that's Europa's shadow there, Io, and there's Callisto's. So that's quite a nice picture of Jupiter. Okay, and interestingly, Saturn goes into opposition this month also. So, so I'm just saying here, hot on the heels of Jupiter, Saturn is in opposition on the 20th of July, just a few days later. Not so easy to spot with the naked eye. You can still see it, it appears as a sort of a dull star, but even with a small telescope, you can see the rings. I remember when I was a child and we got our first telescope, the absolute joy of spotting Saturn and seeing the rings for the first time is something that will stay with me forever, I think. So yeah, they're very close together. Another interesting part of the sky here, we've got a whole series of nebula and clusters in a very, I'll just go into stellarium. Let's see if we can find stellarium. Yeah, I'll give you a better look at that. So my computer finally catches up. So here we are. So this is what I've been talking about. There's the moon there, there's Saturn, there's Jupiter. So this is the cluster very close to Jupiter of interesting objects. So there's some clusters here which you can see with binoculars and some quite bright nebulas. The Eagle Nebula is a famous nebula, which if anybody's seen the pictures that Hubble first took of the pillars of creation, they are a part of the Eagle Nebula. I've shown pictures of that before. The Omega Nebula here as well. But there's some interesting clusters of stars here, the Sagittarius star cloud also. We're actually looking at a section of the Milky Way here, which is why there's quite a bit of activity. But it's worth just going out with a pair of binoculars and just looking at this bit of space here. You'd be amazed what you can actually see. So just zooming out there a little bit, we'll move around a little fraction. So there's Jupiter there and Saturn we were looking at earlier on, so almost directly south, still quite low. And I'll swap around a bit further. There's the moon, and just coming into view here is Mars. So it's still quite low. It's in the east at the moment, but not in opposition, but still quite easy to spot because of its colour. It's quite an orangey coloured object, so you can recognise it pretty quickly. So that's the main things to look at. This just go back to my presentation. Where was he? Wrong one. Anyway, let's just go to the last slide. Just zoom through it. Sorry about that. There we are. That's my last slide. So yeah, that is really my talk on the night sky for tonight. So what I'd like to do now, just quickly ask if anybody's got any questions.
Hiya, Martin.
Hi.
Hi, it's Karen. I was just wondering what time you were saying, early in the morning or late at night for the comet and for the planets. What sort of times were you meaning?
For the comet, unfortunately, it's not really coming over the horizon at the moment till about 3-ish, half 3 in the morning.
Right.
The planets, as soon as it's dark, you'll be able to see those in the southeast, depending on your view. So
yeah, and the weather.
and the weather, yeah.
Usual.
Jupiter's a very bright planet, and it looks like a lot. If you didn't know it was a planet, it would be the brightest thing you could see in the sky, apart from the moon and Venus. And Venus is on the other side at the moment. It's on the west side rather than the east side. So there's no real
Saturn time. Saturn, what time were you?
Yeah, that's similar time. They'll be quite close together. So unfortunately, it doesn't really get dark to about 11-ish, half 11 before you're really going to be able to see anything this time of year. Unfortunately, we've got, well, it depends on your point of view. I mean, it's quite nice to have long light evenings, but for astronomers, it's a pain in the proverbial.
Yeah.
But the comet,
quite late anyway, so right.
Even when the comet's going to be quite visible, you're still going to have to get up to go and see it, I'm afraid.
Okay, thanks ever so much. That was really interesting. Thank you.
You're welcome. Any other questions?
Can I ask one? I've seen noctilucent clouds on the northern horizon about 3 nights last week, looking down. So it's always worth having a look low down. I can see it from my loft room. And I've caught them several times. About 10:30, they're clearly, they're silvery. So it's always worth having a look north.
Yeah,
later.
Definitely.
Yeah, and they've been 3 times. Yeah.
We were talking about this earlier on. Yeah, they are really spectacular this time of year, and yeah, certainly worth a look. And obviously, in the twilight period, it's a good time while you're waiting for it to get dark to have a look at something. It's quite nice to look at those. Okay, well, if there's no other questions, I'm going to introduce our main guest for this evening. I'm very, very fortunate to be able to introduce Nick to our group. I've known Nick for a little while now, and he's a really super chap and talk to anybody, and he's always glad to come and talk to our group. But people don't realise his abilities and his skills. He's probably the top astrophotographer, especially for deep sky objects internationally. And he's written many books, and I'm just going to quickly plug this one for you, Nick. I'm reading this at the moment. Brilliant. Shooting Stars 2. Go and buy it, everybody. So without further ado, I'd like to pass on to our special guest, Nik Szymanek, to talk about his latest venture. Thank you very much.
Okay, is that working?
Yeah, I think so.
Is that, you can hear me okay? Yeah, yeah, okay. And can you see that okay? Yeah, brilliant. Okay, thanks. Right, well, as you can see from the first slide, the subject is adventures with robotic imaging. It's something I've been involved with for quite a few years now, and I'll explain that actually with the next slide. Oops, let's make sure this is working. This is my own back garden observatory. It's about 100 feet away from where I'm sitting at the moment. And since we moved to this location about 4 years ago, it was a priority to get this set up. And once you've set everything up and it's working, I'll literally just come back indoors and control this from inside. So in a very real sense, this is already a robotic telescope. And the kind of view that you get, that's just a shot of the telescope that I'm using at the moment. You can see it's a 10-inch telescope with a small refractor on the back and a CCD camera on top of a paramount. And it's all contained within this 10-foot dome. But as I mentioned, it's all set up to operate robotically. So on the freezing cold nights, it's really nice to just sit indoors in where I'm sitting at the moment in this room and you know, capture these images of the sky. But having said that, I probably won't show you any that were actually taken with this scope tonight. This is the kind of thing I'll be looking at when I'm controlling the telescope from indoors. So there's planetarium software on the left. In this case, it's the SkyX, but very similar to Stellarium, which Martin just demonstrated. And because I'm working with two monitors, on the right-hand side, this is the observatory control software. And these are just the files that are being saved to the hard drive in the observatory, and they're just transferred wirelessly indoors to the computer I'm sitting on at the moment for image processing. So this is a typical view of what I'd be looking at most of the time when I'm sort of imaging. You can see a very short exposure of M31 just in the background, a tracking error graph here in real time pretty much, so I can monitor how well the guiding's doing. And then on here is all the camera control information. So it's all robotically controlled from indoors, and that applies of course to changing the filters, to altering the focus, which is done actually autonomously by the software. So once everything's up and running, I can just come indoors and either, you know, sit up here and watch it all going on, or go and watch the telly or something like that. And it's a very nice way of working. But that's just a kind of sort of introduction. But in reality, robotic imaging is based around places abroad where the skies and the conditions are much better than here in the UK. So at the top of the slide here, the advantages are access to prime imaging locations. That may be Chile, Australia, Spain, you know, parts of America, all the sort of the darker skies. Access to southern hemisphere targets, again, you know, stuff that we can't really get from the UK, and also access to high-end imaging equipment. Now, there's two distinct routes you can go down if you're interested in telescope remote imaging. On the left, you're renting time on a telescope rather than using, you know, purchasing your own equipment. The advantages of that, there's no outlay on equipment, which obviously is very expensive. You only pay for the time used on a particular telescope, and you should always be refunded if there's any downtime due to bad weather or instrumentation problems. And you've got a choice of imaging systems, so that's big scopes and little scopes. The disadvantages are it can and is very expensive to actually book time. It can be, and it is very expensive to book time on these telescopes. And you're also competing with other people for time on these telescopes. But, you know, it's workable, and, you know, it's nice not to have any big outlay. You can just book time on these telescopes and get high-end data. The second option on the right is ownership of a remote system. So the advantages of that, you've got access to your equipment the whole time. It's there as soon as the sky is dark. And as we'll see later on, it does allow you to take extremely deep images, something that's proving a bit difficult to do in the UK. The disadvantages, of course, are, you know, the expensive equipment costs. You know, there's no illusions. You can't buy cheap stuff and install it in these locations. So there's a big outlay there. And you're also paying a monthly fee, and, you know, maybe maintenance and troubleshooting fees as well. But, you know, I'll say right at the outset that for people who are interested in this, in both of these, options, you know, you can approach it from the point of view of like a group of people and you know, cut the costs between you. My old astronomical society, Havering, they've got a group of about 6 or 7 people who are buying time on a very good telescope system, and they're just keeping the costs down. They just share the data between them. That's a great way to go. Now, this is quite an old slide, but a couple of years ago, I just typed in remote telescope operation, and you can see loads of these different options have come up. Probably some of these might not even be around anymore, but if they aren't, there will certainly be others that have taken their place. So there's plenty of options for you to look at. Now, my first introduction to true robotic imaging was on this scope. So it's quite a nice, you know, your first sort of robotic telescope is actually a 2-meter telescope in Hawaii or Australia. And this was the Fawkes telescope. And this was when it was being bought online, I was contacted by one of the sort of directors of the system, and he said, you know, we're getting this scope up and running. Would you be interested in having a look at the data for us, sort of processing the data? So I said, yeah. And, you know, sort of worked with them for a few months, and they said, okay, this is all good. You know, would you like some imaging time on the telescope yourself? So that took me about a nanosecond to answer. And I said, yeah, let me have as much time as you can. And in the early days, I was given quite a lot of time on the telescopes, and it was good because it was in a development stage, and we were getting some very good data. The upshot of this experiment, though, with the Fawkes telescope was that it's designed to be used by school children. It's designed to get children interested in imaging the sky, with professional level telescopes. And with the telescopes that were available, in this case on Hawaii, or the second one in the Southern Hemisphere in Australia, the time difference was such that when the school kids were at school, it was dark in those locations, so they could log on and control the telescope in real time. In fact, at one point, they even had an infrared webcam available that you could see what the telescope was doing. They could see it sort of moving and stuff like that. Now, the interface was very simple. It was designed to be used by kids. So, you know, there was hope for us as well. So it was just a case of setting what filters you wish to use, the exposure times, whether you want to use binning, which I won't sort of bother you with the details of that. But you actually set all this up, and then your time on the telescope would count down, and then it would suddenly say you've got control of the telescope, and off you go, and you can do your own sort of imaging. And that was really good. We had a couple of years of that where it was really good fun to use. And I spent a lot of time imaging with the telescope. Now, the thing, what my interest in the scope back then was that, you know, you go on their sort of catalogue of library of images that people take, and there'd be like thousands of 3-minute exposures of the Dumbbell Nebula and the Crab Nebula and stuff like that. And that was fine. That was great for the kids. But what I was really interested in doing was expanding the field of view, because the original field of view, it was only about 4.5 arc minutes. So galaxies like this didn't fit very readily on the chip. So I spent a lot of time working out systems where, at the moment, these are just multi-filtered exposures just with the imaging chip. But you may recognize this one. This is the Eagle Nebula, the Pillars of Creation. This is a narrowband image. And what I decided to do after using the scope for a year or two was to try and take mosaic images. So the idea being that you'd plot the position of one of these objects, in this case, the Dumbbell Nebula, and this was the field of view of the telescope. So what I used to have to do was work out the central point here, make a note of it, then move the box up to here, and do the same thing, then here, and then here. So you've got four sort of panes, which you can then sort of put together to take like a much wider field of view. And no one else was doing that at the time, so it was really good fun to be doing this. The obvious thing you have to do is work out your coordinate system very accurately, but also make sure you allow plenty of overlay between the images, because the last thing you would want to do is combine 3 of them and find out there's like a little gap of bits that you've missed. And the end result, of course, when you're working with these narrowband filters, you can readily see how different the Dumbbell Nebula looks through hydrogen alpha, oxygen 3 and hydrogen beta filters. But then when you combine them all together, you get a nice sort of highly detailed view. And one thing I've always said, I have a lot of correspondence with imagers around the UK. And one of the things they always ask about the dumbbell, or one thing I always say to them, is that if you can resolve these 3 stars really clearly, then it means your seeing conditions are quite good and your focus is good. But of course, on a telescope, on a telescope of this size, it's readily very easy to sort of resolve details like that. And this was another target shot with the telescope in Australia, which is Centaurus A. And we'll come back and have a look at that a little bit later on. The Crab Nebulous was mentioned earlier on, lying at a distance of 6,000 light years, I think. This is another four pane mosaic. So these things take a lot of setting up. And in the center, the lower of these 2 stars is the star that has exploded as a supernova, causing the Crab Nebula. And the explosion was so sort of titanic that the core of the star has been compressed down into a neutron star. And rather sort of interestingly, I'm not sure if you can see at this scale, but just to the right of the Crab pulsar, you can see these little sort of almost vertical strips here. And these are actually outflow. This is outflow material from that central star. It's a very violent place, hugely strong magnetic fields, high energy radiation. It's, it's a very, very sort of violent place. And it occurred to me, with the resolution of this scope, would it be possible to actually capture movement in the nebula, even at a distance of 6,000 light years? So I shot a couple of single frame images over the course of 2 or 3 months, and then combined them together into a 3-frame movie. And indeed, you could see those pulsar winds actually kind of, this material moving away. And there was actually a change in the nebula itself. And of course, when I sent this movie to the Fawkes Telescope people, they were really sort of pleased with that. It's predicted that we'd be able to see these, but it's great to have it sort of proved. Anyway, that was the Fawkes Telescope. The reason I ended up not using that anymore, it was being turned over more and more towards sort of professional imaging. So on many occasions, I'd book time on the telescope and work out all of these sort of complicated procedures. And, you'd be monitoring the seeing and the conditions, and it'd be great. And you'd just about be ready to start. And it would say, oh, sorry, you don't have control of the telescope. And you do a little bit of research later on. And it turns out it was, there'd been some sort of faint nova or something discovered, and they'd sort of kind of overridden the amateurs' use of it to take data, which is, fair enough, I suppose. But I just got a bit sort of fed up with getting booted off after sort of putting a lot of time in it. So I jumped forwards quite a few years now, and we decided to set up a system at this location here, which is a place called Nerpio, the Astro Camp in Nerpio in Spain. And you can see it's quite a good location there, sort of quite high. And we had sort of, many a happy imaging session there. But I'll show you some images from there in just a second. But for now, again, apologies for all the text here, but let's think about, if you decided to set up a system yourself, what sort of equipment do you need? And most of this is fairly self-explanatory, but I'll just run through it quickly. So if you're going to be imaging, which of course that's what you're doing, you've got the option to go for a wide field refractor. And these are great because they are low maintenance. There's no worries with collimation or anything like that. Nice wide field view, very easy on the pointing, very easy on the guiding. And these are really nice sort of telescopes to use. For more high resolution imaging, for things like galaxies, then you're looking at sort of 10-inch plus scopes, Ritchie-Crescent design, modified Dall Kirkhams like the Celestron Edge telescopes, and anything sort of upward, but they're a little bit more high maintenance to actually keep running. Now the equatorial mount's probably the most important part of the whole system, and it's worth choosing wisely here. You must have good pointing and tracking capability without any sort of aggravation, and good options include the old Paramount MH, which is what I'm using at the moment, the MX, the ME2, 10 micron mounts. There's very, very high-end mounts, and there's others, as we'll see in a minute. CCD camera, well, plenty to choose from. What you're looking for is efficient cooling, good quantum efficiency, good sensitivity. That means if you're able to work with a inbuilt off-axis guider, and you must have an electronic filter wheel to control the system remotely. Focuser must be fully robotic. You know, there's no one there to focus the telescope for you. You have to be able to control the system yourself. So we use autofocus routines using ones that are on there. There's plenty of good focusers. You know, this is becoming much more popular now, so there's plenty of good focusers are out there. A rotator fits on the back of the telescope and allows you to remotely rotate the whole guiding camera. It allows you to for better framing and choice of guide star and stuff like that, but it's an extra level of complexity that you probably won't need. And then the auto guider, again, very, very important. As I say, best used with an off-axis guider. Should be sensitive, and it must have an internal shutter, because you also need to take these calibration frames when auto guiding as well. And as for the PC, well, just a decent spec computer, solid state hard drive, plenty of RAM, plenty of storage, pretty much. That's, you know, it's pretty much the obvious thing. Now, this was the first system that we set up in Spain, and we, you know, I said choose your equipment wisely, and maybe we didn't, because this the mount you can see on the screen on paper is a very, very high-end direct drive mount from a company called ASA. On the right is a 10-inch Ritchie Crescent telescope with a carbon fiber tube, similar to the one I'm using here in the back garden, and bolted on the back of that is a separate guide scope. Now, we struggled to get this mount to perform to its specification. It's a sort of mount that needs a lot of mollycoddling. It's a sort of mount you need like 10 foot away in your garden that you can just keep going out and, you know, nursing it into sort of high performance. But as a choice for a robotic mount, it was a disaster. So we struggled with that for ages. We also struggled with the guide scope, and we were getting sort of flexure problems and stuff like that. So we binned that, we binned the mount, brought it back to the UK, and then just installed a good old high quality MX, Paramount MX scope. You can see the thing on the back here, the same scope, but now with an off-axis guider. And this is the enclosure where the telescope was in Spain. Now, obviously, if you're controlling a system using software, you have to have the appropriate software to do that. And I'll just run through these very, very quickly, because it's not too, you know, it's important, but it's, you know, it's more for the sort of images than anything. Obviously, you need high quality internet control. We used TeamViewer for a while. They got a bit sort of ratty, saying, oh, you know, you're using it professionally. No, we're not. So these days I tend to just use software called Splash Top, which I should have put on the graphic, but I forgot. Camera control, there's all sorts of modern software here, probably many more than I've actually put here. Image scripting is important, because, you know, when you're controlling a telescope that's 1,000 miles away or even further, you can get internet latency problems. So it's far better to have a program where you can actually script the whole observing run, including focusing, calibration frames, autofocus, image acquisition, the whole works. If you have a scripting program, it does it all for you. So you can just program it, fire it all up, go to bed, and the next morning you get up and hopefully all your data's on the hard drive. And then for pointing, again, the SkyX, Carte de Sire is another one. There's loads of others, just put a few on there for now. And for processing at the bottom here, these, you know, PixInsight, these are very sort of famous programs. I won't dwell on those too much. And this is the kind of view you'll get of when you're trying to set up an imaging run. This is the SkyX, and all you can see, this is the field of view of the imaging sensor, and that will vary depending on the camera that you're using. And this here is the field of view of and the placement of the guide camera. So when we look at a graphic like this, this is on the Rosette Nebula, we can make sure when we, particularly, you know, if we're using the rotator, that we can choose a nice bright guide star for guiding. But, you know, it's the kind of stuff we do just in the back garden as well. And this is a really boring slide. I do apologize for this, but this is just the scripting software that we're using, CCD Autopilot. And you can see down here all the sort of blurb about when it starts and finishes. And, you know, it's completely boring, but that's what we had to use. And then most of these places have got all their own weather monitoring systems. You know, you can look at statistics for the past and stuff like that. It's all, you know, it just helps you sort of plan your imaging and just see what the general conditions. If they have a webcam there, you know, they're visible at night as well. And quite often we'd be imaging and you could see the Milky Way on here. So, you know, the conditions were really good. Now, to take images in color, we don't recommend, if you're working with a robotic system, to use a one-shot color camera. I mean, you can, but if you're going to go to all the trouble and expense of setting up your own system, then it's worth buying a monochrome CCD camera with filters. And the idea is just take exposure through red, green and blue filters and then combine them into a color image. So it's a bit of ag and stuff like that, but you know, it's the bread and butter, sort of nuts and bolts part of CCD imaging. We take it one step further, and you know, I would always recommend this for any form of imaging, and that's to shoot all of your main data through a clear filter, a so-called luminance filter, then shoot the RGB data, blend the two together to produce what's known as an LRGB image. And if you compare this to that, you can see it's a far superior image because it's using all of the detail and structure and signal from this sort of clear filtered image. And other options are, of course, narrowband imaging. So rather than red, green and blue filters, we'll use sulfur 2, hydrogen alpha, oxygen 3. They all sound a bit weird, but they're basically sort of red, green and blue filters. And something we use, which is very popular now, the so-called Hubble palette. And it's called that because in the early days of narrowband imaging with the Hubble telescope, this is the palette that they created. And I'll show you lots and lots of images a bit later on with the Hubble palette. Now, the great thing about imaging from our system in Spain, because it was our own equipment, we had access to it all night long, you know, we could take these really, really deep exposures of all these different objects. This is the Crescent Nebula. And you know, some of these images are 60 or 70 hours in length, shot over maybe a couple of weeks or something like that. So we'd wait for the moon to get out of the way. This is another one. This is the Iris Nebula. This is an LRGB image. And again, very, very deep exposures. And once you start taking lots and lots of deep exposures, when you add the images together, the signal to noise ratio improves, and you can start to record all these faint sort of bits of dust that short exposures certainly won't capture. And again, you saw this just briefly as a small graphic. This is the Cocoon Nebula in Cygnus. And it's the same kind of thing. You might be able to see on the screen, these stars around here are all kind of red. And that's because there is this faint outer envelope of dust, which is kind of reddening the starlight coming through it. And again, you know, it's quite difficult to capture stuff like that with very short exposures. And likewise here, this sort of underlines another point. You know, we're all familiar with images of the Dumbbell Nebula. It's such a brilliant sort of popular target, and it's well placed from the Northern Hemisphere for us up in Blighty. But the thing is, again, with our system in Spain, you know, we could sort of push and push and push the exposures and then capture this, this sort of rather asymmetric outflow shell. It's a planetary nebula, so the central star is the one that's it's used up all its fuel, it's gently puffed all these layers into space. So you can see there is a kind of radial pattern, a bit like a sort of clock face, and you can see all this material sort of stretching out from here. But again, from UK skies, although I have seen people do this from the UK, but this was a real tough one to process, even with sort of hours and hours of data. This is one of my favorites that we take, and this is M82. And this is like a kind of hybrid image where we've shot lots of LRGB data, but then we've augmented the image with a narrowband filter. And it's that filter that captures all of this outflow material from the galaxy itself. And you can see there's some nice structure in there. And what I always say about this image when I project it at talks, if you look carefully, you can see these magnificent chains of galaxies just all across the image. Up here, for example, there's galaxies everywhere. And once again, this is because not only are we working from a very dark sky site, but because we are taking lots and lots and lots of data. And when you add it all together in the computer, it gives you these nice deep images. But of course, on the other end of the scale, this was the last image we took when from the Astro Camp, because we decided to move to another location. And this was just something like 3-5 minute exposures on a fairly bright galaxy, the Sombrero. But, you know, it does just go to show that perhaps, as we'll see later on, if you're booking time on a sort of a rental telescope, you can get very good results from dark sky locations with high-end gear with very short exposures. This was one of my favorites taken from Spain. This is the Galaxy M33, and again, very, very long exposures, lots of them, and you know, all stacked together. But we purposely shot a huge amount of data through the hydrogen alpha filter to once again capture these glowing H2 regions that populate the spiral arms. So, you know, these are so big, they've got their own NGC catalog numbers. And this was just shot with a 5-inch refractor. But when you see this in sort of high resolution on a good computer screen, it's some incredible structure. So I think we were very lucky, even though this was shot over a period of 2 weeks or so, the seeing conditions were very good. And again, another very deep exposure taken with the same little refractor, 5-inch refractor of the Horsehead Nebula in Orion. This is a more obscure target. Some of the imagers might know this. This is the so-called Mountains in the Mist Nebula. It's part of the Pelican Nebula, and this was shot with our 10-inch scope. And again, something like about 70 hours worth of data in total through the narrowband filters. But again, from these very good locations where the seeing's good, you can start to pick up objects like this. This is something called a Herbig-Haro object. And what this is it's like a pillar of gas and dust. And inside this, at the top, are stars collapsed out of the gas and dust and formed. And it's ejected this sort of, let me get this right. It's a symmetric sort of bipolar outflow. And again, with high resolution, you can capture things like this. So, you know, this is why, you know, these robotic systems are so nice when they're sort of placed in really dark, good locations. More of the same. As you can see, this is the Hubble palette that I talked about earlier on. I won't say too much about it here, but what we're typically, when we're processing these images, and this is something called the Tulip Nebula in Cygnus, the Hubble palette shows these images not like in a red, green and blue palette, but in a palette that shows off reds and yellows and sort of golds and blues, and they're very sort of photogenic, but they are false color palettes at the end of the day. So you have to bear that in mind. This is another Hubble palette image. This is the Pac-Man Nebula up in Cassiopeia. And again, you know, with good seeing and deep images, we can sort of bring out all these they almost look like they've got that sort of Hubble telescope look to them, because the narrowband filters produce nice tight stars and lots of sort of detail in these gas and dust areas. Anyway, we decided to move to another location. This was still in Spain, but owned by an expat, Colin Cooper, who had this lovely sort of great big sort of house on the hill here. Keen astronomy. So I'm going to set up my own sort of robotic observatory here. And Colin's one of these guys that just does it. You know, there's no sort of faffing around or anything, just sort of gets it done. And this was where we moved, but we didn't actually stay here that long because Colin decided he wanted to move to a much darker location. So really we were sort of faffing around with gear, and this is one of the telescopes we were using at the time. But there was a few sort of issues with the mirror and stuff like that. So we decided to just go back to a 6-inch refractor. That was it whilst it was being sort of installed and stuff like that, but it never really performed as well as we hoped. So we took a very deep image. This is about 70 hours of something called the Propeller Nebula. Anyway, Colin decided he was going to move, and indeed he has, and he's moved to a much darker desert location, quite near to the Calar Alto observatory in Spain, which is, you know, a kind of world-class site. I've not been to this location. I've been to the previous one before, but Colin, you know, being Colin, you can see he's got all these different observatories here. This is a drone shot, and you can see all the different sort of systems in here. Ours is one of these. I think it's this one here, and we just got a 6-inch refractor on there at the moment. And this was one of our most recent images taken from that location, and this is the it's called IC410. It's an emission nebula in Auriga, I think, Auriga. But it's got the popular name of the Tadpole Nebula. So you can see these little sort of critters down here. They look a little bit like sort of tadpoles. Now, I've imaged this in the past with my big scope, and, you know, the field of view is about something like that. But we decided to image it with the refractor. And of course, us being us, we took something like about 70 hours worth of data on it. And what we were surprised to see is just how much of this outlying material there is. you know, I wasn't expecting this at all when I sort of combined all the data to produce this. There's this huge sort of outer envelope on the object, which I'd not really seen before, so that was nice. Then the other option is telescope rental. Now, as I sort of alluded to at the beginning of the talk, there's a convenience to this, but there's also a cost involved as well. Anyway, back in January, just before the lockdown sort of descended on us, I was at the Astro Fest, and one of the guys from Astronomy Now, who I sort of write for, he said, "Oh, I'd like to introduce to you some guys upstairs, a system called Telescope Live. Have you ever sort of heard of them?" And I said, "Well, no, I haven't actually, but I thought, okay, you know, I'm not sure what they're going to say." But I went and spoke to one of their guys, a guy called Alex, and he said, "Oh, yeah," he said, "you know, would you be interested in some sort of collaboration with us? You know, we'll give you sort of time on the telescopes, and maybe we'll get you to do some observing tutorials and stuff like this." And I said, "Well, yeah, of course, you know, I'm quite happy to do that." So they signed me up there and then. And when I got home, they were doing a special offer at the Astro Fest. If you, they gave you a little sort of brochure, and there was a little password thing on the back, and if you type this code in, you got something like 60 credits to use on the telescope. So I sort of, you know, tried that out, and was really sort of pleasantly surprised. Now, what's led on from then, I've been doing these imaging tutorials for them, and anybody can access them. All you have to do is sign up to Telescope Live. You don't have to purchase anything or you know, buy anything. You can just sign up, and then you do get access to all the tutorials I've put on there. There's about 10 or 12 on there now. But that's the ongoing thing, and they're giving me time on the telescope. So what I'd like to share with you now is, again, more pretty pictures. I hope you guys enjoy looking at these images. And I'll explain about some of the telescopes that I've been using as part of this Telescope Live system, because this is also Telescope Live are the people that my friends from Havering Astronomical Society have signed up to as a kind of little conglomeration of images, and they're the ones that are using these telescopes to download the data and then share the data. And, you know, it's a way of cutting the costs right down. We can start off with this anyway. This is one of the earliest images I took on there, and this is the Eta Carina Nebula, something we can't see from the UK. This was taken using a Takahashi refracting telescope from Australia. And this is, once again, you may recognize the color palette here. This is the Hubble palette. And again, you know, what I mentioned earlier on was the typical sort of blues and golds and you know, very, very sort of photogenic images. Now, this is a huge field of view because it's a short focal length refracting telescope coupled with a very, very large format imaging sensor. So it's this whopping great sort of multi-degree field of view. So targets like this, which are absolutely huge, you know, they respond very well to imaging with systems like that. And this was also taken with the same telescope. And again, yeah, I'm excited here because this, the previous object, the Eta Carina Nebula, and this one here, which is the Large Magellanic Cloud, you can see the galaxy here. It's like a sort of roughly sort of L-shaped galaxy. And this is one of two satellite galaxies of the Milky Way. And the reason I'm excited was because, you know, as a kid, sort of growing up looking at, you know, spending all my time looking at astronomy books, you'd always see pictures of like the Magellanic Clouds, you know, the Eta Carina Nebula, all these Centaurus A, you know, all these objects which we just can't see from the UK. So as soon as Telescope Live said, you know, and I should point out, incidentally, they've got telescopes in Australia, Chile, and Spain. In fact, one of their or two of the telescopes in Spain are at the same location that we've got our other sort of robotic rig, the place I just showed you, Colin Cooper's place. But for now, again, this very, very wide field of view has been absolutely perfect for capturing the Magellanic Cloud, one of these satellite galaxies, and objects like this, the Tarantula Nebula, which gained notoriety back in 1987, because it was just around about this area here that we were treated, or some of us were treated, to the first naked eye supernova visible since 1608, I think it was. Unfortunately for us northerners, this is forever always below the horizon, so we didn't get to see it, although some friends of mine traveled to Australia and places like that to see it. But for the great thing about a robotic system, you can just log on, you can pay your sort of cash and buy time on these telescopes, and you do get access to these incredibly sort of exotic objects, which most of us can only sort of dream about, or look at these things in the astronomy books. And this is using one of their next biggest scopes. They've got a couple of, when I say next biggest scopes, the jump was from something like a sort of 4.5-inch refractor to now a 20-inch telescope. But this is a Newtonian reflecting telescope sited in Chile. And it's a remarkable scope to use because it's a very fast optical system, f4.5, and it's actually on an ASA mount, like the one that we sort of rejected from the Astrocamp, that direct drive system. And we rejected, and they've got a 20-inch reflector on there, and the performance is absolutely incredible. And I really enjoy using these scopes because they give you these really wide fields of view, perfect for these. This is the, as I say, the Tarantula Nebula, so perfect for imaging at this scale, but very fast optically. And this is one of the cheaper telescopes to hire as well. So I had great fun using these telescopes, but they politely requested that I stop using them because I'm given free time. But they want, they obviously have to sell time on these telescopes. And because they're so popular, they said, we need to sort of keep these for sort of paying customers. My favourite telescope out of the ones out there is this one, Chile 1, which is, as you can see at the blurb at the bottom, it's a plane wave. So it's a very high quality American telescope, a 24-inch telescope, corrected Dahl-Kirkham optical design in Chile. And you can see the mount that it's on, very sort of high in scope. And a lot of the pictures I'll show you now were taken with that telescope. Relatively fast optically as well, 6.5. So that's good. That's in its favour. And I'll just show you some of the images that were taken. In terms of imaging time, these are, I can't remember the exact time of these. I've got it written down somewhere. But these are LRGB exposures, so taken through 4 filters. And these are probably a total of about an hour and a half's worth of imaging, something like that. So, one of the first. This was one of the first objects I imaged using the 20-inch reflector earlier on, right after the Astrofest, when there was a full moon in the sky, and it still produced a really nice image of this galaxy, which is, again, we can't see this from the UK at all. Even from the Canary Islands, it's not particularly high in the sky, but from Chile, it really is. So this was taken under very good observing circumstances. And again, if you look carefully, you can see lots of these external galaxies in the field of view. This is a globular cluster. So there's a few stars there, I think it's fair to say. This is Omega Centauri, again another one of these sort of famous southern objects, which we can't see here from Old Blighty. And this is a bit of an enigmatic object, because if I could say to anybody listening to this talk at the moment, what do you think this object is? Everybody would say, I suspect, well, it's a globular cluster. But it's a bit weird because professional astronomers seem to think that actually it's a core of a galaxy, that wandered a bit too close to the Milky Way, our galaxy, a bit like the Magellanic Clouds, and the gravitational and tidal effects kind of stripped the core out of it. It just sort of, the stars kind of settled down into this sort of globular cluster, but apparently it's not a globular cluster, it's a stripped out core of a galaxy. But every time I look at something like that, I can see that that's a globular cluster. But again, taken under very good seeing conditions. I can't zoom in on the image because this is just a PowerPoint thing. I think I won't risk doing it, but a full resolution on the screen, you can see all the gaps in between the stars in the middle. And then Centaurus A again. I showed you that shot briefly with the Fawkes telescope. And this is a much wider field of view, perfect for images like this. And again, a very deep southern target. And again, this, I really love these objects because they're so kind of different to what we've got up here in the Northern Hemisphere. You know, there's no other, well, there's very few other galaxies in the sky that look like this. And the reason for this, of course, is that this is a collision of possibly 3 galaxies. So the faint sort of spherical thing that you see that sort of really does stretch all the way out here is an ancient elliptical galaxy. And then along comes a spiral, which gets kind of torn apart gravitationally by the interaction with the big elliptical galaxy. And, you know, incredibly enough, although there may be sort of billions or even trillions of stars altogether between the 2 galaxies, when these things collide, the distances between the stars is so big that the stars literally just sort of pass by. You know, there's probably very few stars in this whole object that are actually colliding. But what does happen is the gas and the dust gets sort of churned up, and you can see the galaxy, because of the tidal effects and gravitational effects, the spiral galaxy has literally been torn apart. You can see these dark dust tendrils sort of stretching right out here at the edges of the galaxy. And it's possible that some of the blue stars you can see here may even be the chewed up sort of remains of a 3rd galaxy that's been sort of chomped up once again by the massive elliptical galaxy. So whilst this is just a snapshot in time, you know, at some point in the future, these 3, if it is 3 galaxies, may just kind of converge into one great big sort of super elliptical galaxy. But, you know, it's rather strange that very few of the stars actually collide. And then this rather weird looking object, this once again is the Tarantula Nebula, that thing we saw at the bottom of the Large Magellanic Cloud. But this is now a narrowband view of it, taken with the big telescope. And you can see it gives you a very different view. This Hubble palette is a very different, it gives you a very different view, but because of the different colors involved, you can differentiate different sort of effects that are going on within the nebula. You can see this central part's quite orange and surrounded by all these blue sort of filaments, and down here, you know, the Hubble palette is very good. Not only does it look very nice, it's very sort of pretty, but it does show you these different things are actually occurring within these objects. And then this was one of my earlier ones as well, which I'm very, very pleased with. This is another deep southern object called NGC 1365. It's got some crazy, you know, popular name, which I can't remember for the life of me. But this was taken using their biggest telescope, which is a 1 meter telescope, actually on an altazimuth drive, so it uses computer control and a field rotator to correct for the fact that an altazimuth drive doesn't cancel out field rotation as it tracks these objects across the sky. So that's how professional observatories work with the big telescopes like the Keck, you know, the really big telescopes. And this is an incredible galaxy. It's, you know, it's really one of my favorites. And of course, with under the brilliant skies of Chile, under very good seeing conditions, the resolution on this is very good. And I think out of all of the images that they post regularly on the Telescope Live Facebook page, this one has had about 3 times the viewing of the next most popular one. So this really did sort of strike a chord with the people who are sort of, you know, using the telescopes and just, you know, lurking on the forums, just looking at it. But you can see why, because it is a spiral galaxy. And then this is another target which we can get from the UK. It's very low in the sky at the moment. Some friends of mine have imaged this quite successfully, but because it's so low, this is the Trifid Nebula in Sagittarius, so very close to where Jupiter and Saturn are, as Martin sort of pointed out earlier on, is that part of the sky. Just about see it from here, but the trouble is when you're imaging low down like that, you're imaging through a much thicker sort of air mass, and you get turbulence and poor seeing and stuff like that. And, you know, predictably enough, from Chile, these objects rise very, very high in the sky. So you can see that, you know, the star images are really nice and crisp. And this was always a good test object for us, even back in the days of film, because it's what's known as an emission nebula. So you get all this red sort of light here, and then just to the north of it, there's this sort of bluish green reflection nebula. So whilst this gas and dust is actually physically glowing, this nebula is just reflecting the light of these sort of bluish stars around it. So two types. And when we were trying out films back in the day, in the 90s and perhaps even into the early 2000s, it was always a good test of the film, you know, when we're going to places like La Palma to see how the film performed. I'm going to bring you back to this object. We looked at this earlier on. It was the very first image I showed from the Telescope Live selection of images. And the reason I'm showing it to you again, I'd like you to, you know, we looked at this bit here earlier on, but I started looking at this bit up here, which looks just like a sort of little knobbly bit on the end of the nebula. And I thought to myself, well, this is the field of view you can get with one of these short focal length refractors. I wonder what the view would be like of this with the 24-inch telescope. And it was actually quite nice because it produced a very kind of unusual image. Now, a lot of the times you'll see this from the southern hemisphere sort of imagers, and they'll say, if you look at this bit up here, it looks like a bloke's face. Now, it sort of does. There's like a profile there. So that's his, you might have to sort of turn your head a little bit, but you can see that's his forehead and that's his nose there and that's his mouth and that's his chin. And it doesn't look like a bit of a sort of profile. And it's really distracting, I thought. So I thought what I'll do is I'll actually rotate the image just by 90 degrees. So it's in this orientation. And all of a sudden the image really sort of popped into life. So that was a very good result because, you know, it just goes to show you can image one object with a wide field view, and then you can sort of zoom in and get really sort of nice images of just parts of it. You know, you can do that with things like the Orion Nebula and the Lagoon Nebula and, you know, all those sort of big ones. Now, so this one was talked about earlier on. This is the Eagle Nebula. The so-called pillars of creation. This again taken with the 24-inch telescope. Now, when I first looked at this, it's a narrowband image, obviously taken using the Hubble palette, and I applied some sort of sharpening and that to the image, and it really just impressed me more than perhaps any other image taken, just how good their telescopes are, because you know, you can sort of zoom in and see all this interesting stuff up here in the, you know, in all the pillars themselves. And to be fair, this isn't a huge amount of imaging. It's probably about 2 hours in total. So, you know, that would still cost quite a lot of money to book on a telescope of this size. But, you know, it really did sort of underline to me how good the sky conditions are there and how good the instrumentation is. And this object is again something which I'd never even seen before. I think it's, I can't even remember the catalogue number. It's something like NGC 4567 or yeah, something like that, 4765. I've got it written down somewhere. But its popular name is the Statue of Liberty Nebula. You might be thinking, what's he on about? But I think it's because you've got this dark sort of figure in here with her arm up in the air, sort of holding something, and you can sort of see an amorphous shape down here. So as usual, they've given these silly names, but this one is a hugely enigmatic object. I've never seen, you know, structure like this. And again, it's not particularly deep exposure, but as I alluded to earlier on, the use of these narrowband filters does show you the different processes. You can see like a bridge of material sort of stretching over here in front of all this stuff, the bluey stuff going on here, and these little sort of shock waves and things. So this was a very interesting target for me, something I didn't even know about until I sort of did a bit of research and thought, yeah, okay, so book some time on the telescope, and you know, it could have done with, you know, 10 times the imaging time that I had to do the object justice, but you're still really pleased with the relatively short exposure that you see there. And the latest image that I've taken, which I just finished a couple of weeks ago, and this is the Helix Nebula. And what I'd done for this one, they'd given me some observing time, and I queued that onto the telescope, because you know, you're not controlling these in real time. You just, you know, send your observing proposal to them, and the telescope sorts it all out, and then it says, you know, estimated time of completion, you know, whenever it is, and that can change if the weather's bad or, you know, any instrumentation problems. But I used two lots of scheduled time to book this, because this is the Helix Nebula. It's an object we can just about image from the UK, but like all the other things we talked about, very low down in the murk. But this from Chile, it paid off to take these deep exposures, because what we have here is a planetary nebula. This is the central star, so a bit like the Ring Nebula or even the Dumbbell Nebula. It's a star that's used up all its fuel and just kind of gently sort of puffed itself out into space. But with the deep exposures, you can zoom in and see these sort of, I think they call them sort of cometary globules or something. So once again, you've got this radial structure, which it does need the deeper exposures to. In fact, what I'm going to do, because this is virtually the last slide, I'm just going to see if I can, yeah, okay, that's kind of worked. I don't know, I'm going to zoom out, but although it's just kind of magnifying the image that's on the screen, if you look carefully, you can see these sort of cometary globules and things, but you can also see little spiral galaxies within here as well. And there's certainly a very bright one up there. If I can zoom out again, I think I might have blown this. Oh, okay. You know, you can see other little galaxies all across the field of view. So this was a very, very deep exposure. Another nice one down there. We're really pleased with this, because when you often see images of the helix, this is the part you see, the bit that looks like an eye, but with the much deeper exposures, with the bigger scope, you can see the Helix Nebula itself is actually a much bigger target than you might think at first. So, yeah, when I was sort of looking at these objects in here, you know, I was thinking, you know, are they galaxies, or are they sort of instrument, you know, processing artifacts? So I downloaded this, an image taken with the Hubble Space Telescope, and they do match with the positions of all these galaxies that Hubble's sort of imaged. So I think that's the last of the telescope live talks. I mean, Martin sort of mentioned this earlier on. This is still available from the Astronomy Now website. It covers all of the sort of processing and stuff like that, which I hadn't talked about tonight. That's a separate talk altogether. But if you want to learn or you get an idea of what's involved when you're imaging, because obviously if you are booking time on a telescope abroad, or you're going to set up your own system, you do have to learn how to process the images. So, you know, there's plenty of books. If you do a search on Amazon or something like that, plenty of books on there that you can, you know, pick up and learn how to do all this stuff. Although it does take time. So I think that's the end. So hope you enjoyed looking at all those pictures. I certainly enjoyed putting them all together and using the equipment. So I'll hand you back to Alan or Martin. And if there's any questions at all, you know, if you want to stick around for those, please, you know, please keep them coming. Not Steve though, because he's a troublemaker. So I'm keeping an eye on him down there on the bottom of the screen there. Only joking, of course.
Can I say thank you very much indeed? Absolutely tremendous.
That's okay. We can go on for another 4 hours if you like.
I'm not sure how much recording time, but I can always stop the recording.
That's a polite answer, yeah.
Okay, I'm sure people have got questions. They can either unmute themselves or can type them in through the chat, which is a good way of doing it because we can see them while people are trying to overcome their shyness. Well, you showed that picture probably about 3 slides back with the person's face in it that you turned round. I'm going to spoil it even more and say that I saw a lion's head in it.
Okay. Well, if you want to see, I can actually show you how you know most people choose to show it. This will only take a minute. Remember the name of the bloody object. Make sure I'm on the right one. Oh, no, wrong one. I can't even remember the catalogue number, so maybe this is going to end in tears. Is it 3199? No. Oh, shame on me. I'm really showing myself up now.
Oh dear.
I can't even remember the name of my own images. Okay, well, let's... Oh, yeah, this is it. So if I show you my image but rotated, this will save you having to sort of crane your neck. So you can zoom in now.
Okay, yeah.
So can you see this
Yeah.
is head and this is eye sort of there, and nose and mouth. They've given it some kind of name. I can't remember what it is, after a Chilean poet, I think, some geezer. But again, you know, I looked at it like that and thought it's really distracting because you can see that in there. So where did you see the lion's mane?
Yeah, turn it back the way you had it on your original one. Okay, now on the right-hand side, about sort of between 3 and 5 o'clock.
Yeah.
There you got a lovely lion's head there, 2 eyes, its nose, its mouth, its chin.
I think I can see it. Yeah, yeah.
Spoiled it forever now, isn't it?
Well, I'd rather that than the geezer's boat race, to be honest. So.
Go on then. Who's got some questions there? We got one here from. Oh, we got some coming in here from Jeff Bryant. For the multi-hour images, do you need to limit the inputs from any objects, such as bright spares? Do you mean stars, to maintain the image quality?
Yeah, it's true. It's what I do from here and what we do from Spain with our own rig is to choose an exposure time that is long. It's a trade-off. It's a very, very distinct balancing act. You choose an exposure time that is going to capture enough of the object of interest. So obviously, if it's a really faint target, you'd probably have to increase the exposure time. That's a trade-off against if there's anything really bright in the field of view that maybe will saturate and kind of spoil the image, sort of overexpose the image effectively. Also, it depends on the quality of your guiding system. Obviously, with these rental scopes, they're all going to be very, very high-end scopes and mounts. So it isn't a factor, but if you're working from a, you know, if you're setting up your own system, yeah, as I said earlier on, it's worth investing in a good mount. So you choose an exposure time that the mount is more than sort of capable of imaging. And finally, I mean, particularly relevant for working from home, you're offsetting it against aircraft trails, clouds, you know, Starlink satellites, all this kind of stuff which can sort of nobble your exposures. So what typically when I'm working from home, I'll use 10 to 15 minute exposures, but take loads of them. And the idea being that if in your sort of 7th exposure, 9 minutes through, like a jumbo jet flies through the field of view, which they regularly do, you're only chucking away 10 minutes worth of data. Whereas if you say to yourself, right, I'm going to sort of go really deep, I'm going to take an hour's worth, you know, there'll be about 50 satellite trails in it, from England this is, 50 satellite trails and, you know, helicopters, clouds, light pollution, all these kind of things. So it definitely is, to answer Jeff's original question, it definitely is a case of like a trade-off. Now, with the telescope live systems, I think the maximum exposures you can take on the telescopes is 10 minutes. But you can also take shorter exposures as well. So if you're imaging really bright things, you can get away with shorter exposures. So it's a very fine balancing act. And, you know, as I say, for the years and years I've been sort of imaging, I just pretty much the whole of that time, I've just used 10 or 15 minute exposures, and then you just be prepared to chuck some of them away. It's a trade-off.
Okay, thank you very much for that, Nick.
Okay.
Another question coming in from Dennis. Nick, are you now concentrating on the Southern Hemisphere?
Not at all, no. I've got limited time on the telescopes. Obviously, all the imaging I'm doing from home is, you know, Northern Hemisphere, obviously. The imaging we're doing from Spain with our sort of modest robotic system is pretty much all Northern Hemisphere, kind of, and you know, a little bit of the Southern Hemisphere. But of course, if you've got you know, a robotic system in Chile, then like a little kid at Christmas, you think, oh, you know, what are these sort of faint, you know, interesting objects that we can't see from the UK? And that's for me, that's the real sort of joy of using those telescopes. The things that I grew up reading about in books, like those objects I showed you earlier on, that, you know, you sort of think, right, you know, I'm really going to sort of get an image of this, which I can't get from here. And as I said earlier on, perhaps I alluded to earlier on, with these big telescopes, you can, on big bright objects like, say the Dumbbell Nebula or something like that, you can get away with really good images in, probably just 40 minutes worth of exposure, particularly if you're just using the red, green and blue and the luminance filter. The narrowband filters do take slightly deeper exposures. So no, I'm just kind of, I'm imaging whatever I can from whatever equipment is available.
Lovely. Another question's come in from Gillian. Are those images in your book?
No, actually, some of the older ones are the ones taken from the Astro Camp. Obviously, all the Telescope Live ones, they were taken after the book came out in October last year. But that book and its predecessor, which you can probably still pick up on eBay, Shooting Stars, the original one, that has got a gallery section in there of colour plates of a lot of the ones that were shown from Nerpio earlier on, like M33 and the ones that are visible from Spain. So loads and loads of images in there, but the Telescope Live ones, they'll have to wait to go in the next book now, if there is one.
It's strange that, because Gillian actually has followed her question up with time for another book.
Yeah, I agree. The great thing is, I've been writing for astronomy now for probably about 20 years now, and the masterclass monthly thing I do on imaging for about the last 10 years, I think it is now, and they give me really a lot of control over. So the 3 books that I've done with them, they just give me sort of, carte blanche, I think is the term, to do whatever I like. And obviously, they do a very good job on the production side, the way they lay it all out. And, the books themselves, I think, are very reasonably priced. And, hopefully in Shooting Stars 3, I can include a lot of these images. So yes, Gillian, they will all go in there, but that might be another year or so before that actually happens. We'll see.
Read the first books. Okay, another question's come in from Lucy. What is the best starter object to look at? What would you recommend?
Well, it's a good question. It depends on the time of year. If it's winter, the obvious choice would be something like the Orion Nebula. But because it's such a big and a bright target, it's visible in the winter sky. And it's visible around the world effectively because it's very close to the celestial equator in the sky. So it's visible from the northern and the southern hemisphere. So if you booked time on a scope at the Orion Nebula, you could get away with very, very short exposures and still get a lovely color image. And the other ones that, a lot of astro imagers start off imaging, myself included, were things like the Andromeda Galaxy. So if you booked time, for example, on one of those small refractors, you can get the Andromeda Galaxy in there very easily. In the winter sky, in the summer sky, objects like the Veil Nebula, the supernova remnant in Cygnus, the Dumbbell Nebula that we saw earlier on, that's a very big, bright, colourful target that responds incredibly well to all sorts of filters. Excuse me. And things like the Crab Nebula, which is quite faint, but if you're using a high quality robotic telescope, then you'll get great images of it. And these are very bright in comparison to, say, the image that you can see on the screen at the moment. So it does just depend on the time of year, but it's just worth doing a little bit of homework. And there's plenty of really nice bright targets that are available throughout the year. For example, just to finish off on that question, the springtime is galaxy time. So, there's hundreds of really bright galaxies to choose from. In the autumn, as I said, M31 and M33, which we saw earlier. Plenty of good targets out there.
Thank you for that one. Ted has sent a question in. You speak of losing runs due to jumbos, etc.
Yeah.
But what I would like to know is how reliable is your home system? How often do you lose time due to mechanical or electronic failure?
Good question. Thankfully, with my home system here, it's it's completely reliable every night. You know, I've invested quite heavily. If you remember that earlier slide, you know, so things like the Paramount, you know, they're high-end mounts, they're observatory class mounts, and what that gives you is repeatability every night. So, you know, it points spectacularly well, it tracks spectacularly well. Having said that, over the last 6 weeks or so, well, actually over the last year or so, I have been battling with a really insidious problem. And I won't bore you too much with the details, but the two pieces of software I use in there, which is the camera control software and the Sky Planetarium software, you can get a piece of code that links the two together using something called an ASCOM driver. And that gives me just a tiny little bit of extra functionality, which is worth its weight in gold. And I won't even bore you with the details of that. But about a year and a half ago, that little piece of ASCOM software kept kind of failing. And I couldn't resolve what it was. And the only way I could get it working again, and this is for any sort of computer savvy people, you'll be sort of, you know, doing this. The only way I could get it to work again was to do a system restore on the computer, which used to take ages, and it reverted the computer back to an earlier state, which then worked. But, you know, the idea is you might go out there in the evening and thinking, right, here we go, lovely clear night. And then this functionality would go, and it wasn't a showstopper, but it was like, oh no, I'm really going to miss that. And it kind of, you know, I've got to spend an hour and a half doing a system restore now. So it was kind of driving me nuts. And then about 2 months ago, I'd go out there, and even when it's not being used in the summer, I'd go out and fire it all up every week or so, just to kind of get all its juices flowing, just to make sure it's all working. And I got this message that as soon as the computer was switched on, your hard drive is about to fail, back up all your day, press continue. So I thought, well, okay, so I press the enter key, and it worked okay. But from that point onwards, I got that error message every single time. And the computer just slowed to a kind of, you know, kind of like so slow, it was just doing my head in. You know, when the sky is clear, you just want to get out there and get going. So I just said, right, enough's enough. So I went out a couple of weeks ago, I just online ordered a new observatory laptop and put all the software on, and it boots up in about 10 seconds. All of the software is up and running within a minute. And it did seem to have resolved the ASCOM problem so far. You know, it still could come back like it did before. This problem used to occur about every 2 months. And then, you know, I'd have to do the system restore. So I went out there today and I thought, well, I'm just going to fire it all up and make sure it all works. And I fired it all up and it said, can't link to the software. I thought exactly the same problems before, but it turned out it wasn't, thankfully. What it was, several of the ports on my powered USB hub in the dome had failed. And one of those was the mount, and the other one was the filter wheel. So those two objects wouldn't connect via ASCOM. So I thought, oh, actually, that was actually quite a relief in a way, because it meant that the original problem hadn't recurred again. So I've just ordered another hub, which will be here tomorrow. So it's a very long-winded answer, but it's a double-barreled answer. In general terms, all the equipment, it just performs brilliantly every night. I'm using the same telescope for the last 10 years. The mount's probably about the same as well. It was only these problems with the computer and now the USB hub that have caused any sort of issues. But that's what you want. You want to be able to go out there every night and get repeatability when you're imaging, because you can learn the ropes. And if you're troubleshooting every night, it's really, really horrible to be out there under a nice clear sky and just sort of faffing around with computer hardware and stuff like that. So sorry, a bit of a long-winded answer, but I hope that's kind of sort of put it into perspective.
I think it's probably given us all a little bit of reassurance when our own computers do similar things in different software.
Oh, I love computers, but you know, I just hate faffing around with them all the time. They're always, and you know, I don't know what it is about observatories. You can go out the night before and everything's absolutely fine. You shut it down, go in, go out the next night. You haven't changed anything. You haven't done anything. You fire it up and then you get like a problem, and then you just have to spend God knows how long resolving these problems, which you shouldn't have to resolve at all. Have the patience of a saint sometimes, that's for sure.
Oh, well, that goes with the hobby, doesn't it? Of
It does. It
astronomy.
does.
Another question come in here. This one from Richard. Great talk, Nick. How
Thanks.
how much imaging is spoilt by satellites, etc., from these
Well,
these remote imaging sites?
very few, fortunately. And if you find that you get one of the frames that has a satellite through, you can still use that because there are sort of rejection sort of algorithms that can be part of the image processing routine that can say, well, you know, all the other frames haven't got that line in it. This one has. Do you want me to just take it out? And you say, yeah, and you know, just kind of to an extent. Fortunately, from our observatory in Spain and the Chile scopes, it's quite unusual to actually get a satellite trail from here in the UK, particularly in the early evening. It's much more problematical now. There's obviously a lot more hardware up there now that it's quite routine to take a 10-minute exposure and to have 4 or 5 separate satellite trails through it. And again, this comes back to what I was saying earlier on. If you took an hour exposure, you'd probably have about 100 in there, and then you just have to sort of trash that data. So 10 minutes, it's getting worse though. I went out looking at these Starlink things once they were launched, and you could just see them going across the sky one after the other. I counted about sort of 50 the first night, I think.
Yeah. I think Steve has also made comment about the effects of those. Dennis sent a message in about your computer problems and just says, was it a system update issue? Well, I guess the answer is we would never know.
Well, originally I had wondered if the thing that was knocking out the ASCOM driver was a Windows update. So I turned all the Windows, that was a Windows 8 computer back then. I turned all the updates off on that, and it still did it. So it wasn't it seems it wasn't, but I posted this problem on the forums, and no one's been able to come up with anything. So I'm kind of on edge at the moment. I've got the new computer in there for about 2 weeks, and apart from the glitch today, it's been fine. But I know that problem, if it's a software problem, it could reoccur at any point.
Fingers crossed that it won't happen. Got another comment here. Let me have a little look at this one. This is from Karen. I wonder how much worse satellite interference will become now as Elon Musk sends more and more into orbit.
Unfortunately, I think it will only get worse. I know they're trying to kind of, it's a bit like locking the stable door after the horse has bolted. They're talking about sort of painting these things black now and angling them at certain directions so they don't reflect the sunlight and stuff like that. But I don't think they can do anything with the ones that have already been launched. I know there are hundreds more. So, it's possible that, when they first launched them, they were in a very low Earth orbit, so it was easy to see them. But I think it's possible once they get into their sort of parking orbit, they might be less bright. But, our cameras are so sensitive now that, you can pick up really, really faint things. Just with short exposures, it's like light pollution. It's great having a really sensitive camera, but even though I live in a fairly dark sky location here, I go out with a DSLR, and a 5-second exposure will almost swamp it if I'm looking towards the south. So it's not good by any means. It's only going to get worse as well. So it's a bit depressing.
I guess that's the price that we have to pay for progress for the masses. Are there any more questions we've got from anyone?
Can I say something?
Yes, go ahead.
Everyone needs to get the book. 130 pages. It's only $10.99, and it is absolutely crammed full of incredible pictures and so much information about astrophotography. Seriously, go to the Astronomy Now website and get it. The only thing is, Nick, we're going to have to wait until we see you in person for you to sign them.
Yeah, of course. Yeah, yeah. Well, I think at the Astro Fest, because the book had only just come out, and I was only there on the Friday, and they said, "Oh, would you mind doing like a sign?" I said, yeah, of course. Love talking to people about imaging and astronomy and stuff like that. And there's a few familiar faces. There was a queue of about like 100 people, if not more, throughout the session. And it's great. They were, the Astronomy Now people were really happy because it sold very well. And I just love talking to people about imaging. So, and a lot of what surprised me, perhaps more than anything, the first thing I ask people who design the book, what sort of gear you're using and all that. And a lot of them, probably at least 50 or 60%, are people that haven't even got any imaging equipment at all. They're sort of buying it for possible use in the future. So yeah, that was nice. Well, thanks, Jerry. Thanks for the.
Okay. I'm happy to promote it, even though you weren't there on the Saturday when I was to sign the
Yes, unfortunately, I had something on in the evening, which after going up there on the Friday, I really wanted to do the Saturday because it was great. I really would have liked to have gone the second time. So.
That image, which is still up, of 3324, I have sent you an email with that and my doctored version of it showing the face that I can. So something for you to look at afterwards.
Okay, thanks. Yeah.
Okay, thank you very much indeed for that, Jerry. Right, I think that's all the questions we've got there. What I would like to say, Nick, as well as the big thank you for tonight's great talk, is if you want to do a little advert about your books, we'd be quite happy to pop that onto our website so that people can order them directly or through any recommended suppliers that you'd like to nominate, because I'm sure that following the talk there's going to be those people who are going to say, what was the name of that book again?
Yeah.
So on like that. So
yeah.
prepare us a little advert.
Thanks.
We'll stick it on, no charge at all. So thanks ever so much again, obviously, as I said, for that really super talk there and those outstanding photos, and the hours of work that you must put into them to produce them. You talk about sort of 70-minute exposures, and then sort of some which take hours, as if it's nothing. It's a real sort of tribute to your dedication, of how much you've learned, absorbed, and so willingly share with others, that I think it's a tribute to your brilliance. So thank you very much indeed.
Thank you very much, Alan. Yeah, thanks very much.
I'd also like to say thank you again to Martin for his part of the talk earlier about the night sky, things to be looking forward to there. So very much appreciate your work there, Martin, and the work of Haggas, who put together lots of terrific experiences for people who want to take up astrophotography. We are extremely privileged to have a group of dedicated people like that within our organization and the contacts they have made. So thank you very much indeed to all the members of Haggas. To everyone else, thank you very much indeed for coming along this evening. As I said, there will be a recording of this posted on YouTube, and the link to it will be through our website. You'll find other meetings there as well. Other than that, it's to say, have a little bit of a summer holiday now. This was actually the very first time we've ever had a meeting in July, and we had a really good turnout. Our next meeting, the next scheduled meeting, is on the 9th of September, again another Zoom meeting, and we've got Roger O'Brien, the president of our astronomy group. Roger is going to be given a talk about the James Webb Telescope, so that's something for us to all look forward to. So on behalf of the Hertford Astronomy Group, let me say thank you to all of you for participating tonight, and we look forward to seeing you again sometime.